In this video note, we shall look at solving one of the exercises in the chapter. The exercise involves displaying the 24-hour value of a clock display in 12-hour AM/PM format, for instance 10.30 PM rather than 22:30. In this solution, we're not going to change anything about the way the number display objects store the current time, but just change the way in which the time is presented by the clock display. This will involve changing just the update display method of clock display. We shall solve the problem in a succession of small steps, as is our practice, and along the way we'll introduce the idea of writing an additional helper class to make our life easier when it comes to testing our changes. In order to get the most out of this video note, you should already be fully familiar with the clock display project and have explored it thoroughly. We start by opening a separate copy of the clock display project so that we don't lose the original. You can either copy the clock display folder within your file system browser or use the Project Save As option within ofwj. The version we already have open is the copy. The update display method in clock display is the place where the clock's display string is prepared. We can think of update display as providing us with a particular view or representation of the data stored in the clock. We can obtain different views of the data simply by changing the way in which update display formats the string it returns. As the first simple step, let's change the colon symbol to a dot or period, and then test that this change has worked. While testing such a simple alteration as this might seem pointless, it is consistent with the approach we like to take of making relatively small changes and then testing to make sure that things are working as they should. That way, if we ever encounter something unexpected happening, we should be able to locate the source of the problem within a very narrow portion of the source code. However, what will quickly become clear is that this testing process is going to become more and more time-consuming as we work with larger programs and as we have to test more cases. There is a danger, therefore, that we will give up this testing approach or be tempted to do it less thoroughly because it's taking up so much time. One way we can avoid this danger is to automate the testing process. What do we mean by that? Well, the obvious thing to use for a task that is boring and repetitious is a computer. Why don't we write a class that will take care of the testing for us? We will write a new class called testClockDisplay and define just one method within it called test. In that method we'll put all of the things we would otherwise have to do by hand over and over again. Here's how we might start that class to repeat the test we've just done. Now, each time we want to retest what we've done, we can simply create a test clock display object and call its test method. It also becomes very easy to add additional test cases if we find we need them. For example, as well as testing the output for 22:30, we might want to test the output for 10:30. This can be done very simply as follows. Now that same call to the test method gives us two results, and we've saved a lot of time over interacting directly with clock display objects. Actually, the approach we've taken here is rather simplistic, and it would not scale particularly well to large programs. However, for a program of this scale, it's actually going to save us quite a lot of time. Test automation is quite a big topic, and we cover it in a lot of detail in a later chapter of this book. But for the time being, this very simple technique will actually make our life a little bit easier, and more importantly, make it much more likely that we will actually keep on testing after each small change. So now let's tackle something more significant. The identification of whether the time is AM before midday or PM from midday onwards. To determine this, we simply have to decide whether the hour is greater than or equal to 12. So let's add that test. Firstly, we're going to need the actual integer value of the hour rather than its display value. So let's store the current hour in a variable. At this stage, we won't replace the call to get display value at the end of the method, but we will make a mental note that this will need doing at some point. Again, we're following the principle of making small changes each time rather than big ones. We need a new string variable to store the AM or PM suffix, so let's define a variable for this. Notice that, just as with the hour variable, the suffix variable is defined as local to the method. It would not be appropriate to define either as a field of the class, because that would imply that they have something to do with the state of a clock display object. No, these variables are simply required locally within this method to help the method achieve its task. Try not to add extra fields to a class, even if it appears that the same variable might be used in different methods. Fields should be reserved for features of a class that are genuinely part of its general character and not for temporary storage. Now we can write an if-else statement to work out whether the suffix string should be AM or PM. Take care over the test to be sure whether it should be greater than or equal to, or just greater than. Notice that we did not have to give the suffix variable a value when it was declared, because the if-else statement that followed was guaranteed to set it to one of the alternative values. Of course, we could have initialized it to one of the suffixes and then just tested for the other. But we'll stick to our original approach. Now we can just append the suffix onto the display string at the end. Remember that we know already that the display string will not be correct for PM output because we haven't made any adjustment to the hour value to correct it to the 12-hour range. That doesn't matter yet. In fact, it will actually help us when we test because we shall be able to see that any times with PM suffixes are indeed after midday. Let's compile and test. At this point, it's probably worth adding a couple more times to be tested. Let's make sure that midnight and midday are properly classified, for instance. Recompile and test again. Everything is looking fine so far. Now for the adjustment from 24-hour values to 12-hour values. This should just be a case of subtracting 12 from the hour value of afternoon times, so let's do that. In order to see the change, we now need to replace the call to get display value for the hour. In the 12-hour system, we don't need to format hour values using 2 digits. Leading zeros aren't used, so we can just concatenate the value of hour to the rest of the string. We compile and test. And we find a problem. The midnight and midday times are wrong. Both say 0 when they should say 12, but the other times are correct, so it just looks like we have to make a special case of those values. Let's do that. Again, we compile and test. Whoops, we have an error because midnight and midday still aren't correct. Well, we know we don't have far to look, and a little bit of thought should make it clear that we made the correction too early, before making the 24 to 12 adjustment. Let's fix that, recompile and retest. Now things seem to be working properly. To summarize, we've provided a fairly sophisticated change to the way in which the current time is displayed through making a localized change to just one method of the clock display class. We made the changes in small steps, retesting at each point to make sure that we picked up errors quickly. In addition, we introduced the idea of using a helper class to support our testing discipline. This made it much more likely that we would repeat the multiple tests often enough for them to be useful. Good testing is a whole topic in itself, and there's a chapter devoted to it later in the book.